This video demonstrates DEMI, a component of the Horse platform, and its ability to rapidly detect attacks that exploit exposed NEF APIs in 5G core networks. In the testbed shown in this image, we have a 5G network with the NEF API endpoint. There are the attackers, the normal users. The attackers flood the NEF API endpoints with many concurrent requests, causing service degradation. In the testbed there are also several Horse platform components such as preprocessing, DEMI, DTE, and IBI. All these components are up and running. DEMI component has already been trained on 20 days of historical NEF data collected during a no-attack period. Horse can prevent NEF API exposure attack because it tracks the number of requests originating from each source over a time interval, significantly reducing detection latency. API requests incoming to the NEF are collected using FileBeat and then passed to Smart Monitoring, which stores these data in the Elasticsearch. This allows another Horse platform component, named preprocessing, to read and process the data. The preprocessing aggregates incoming requests addressed to the NEF into 2-minute time bins. Every 2 minutes this information is sent to DEMI, which elaborates it with its 2 hierarchical levels of machine learning and obtains an accuracy level indicating the possible risk of an exposed NEF API's attack. The results are then sent to DTE, another Horse platform component. DTE handles this information and relays the appropriate intents to IBI, the final Horse platform component involved in this demo. IBI, based on the received intent, decides on the consequent action, for instance, a mitigation action. The display here is going to be organized in 4 quadrants, each dedicated to a specific Horse component whose interactions we'll demonstrate. The bottom right quadrant visible now refers to IBI log and dashboard. In the top left quadrant we have the pre-processing log, the top right is dedicated to DEMI, and the bottom left to DTE. In this video we will show how the pre-processing component constructs a message containing the counters of NEF API requests generated by each of the 5 attackers and each of the 5 normal users and delivers it to DEMI. Then you will see that DEMI receives it and, after a few seconds of computation, sends the result to DTE, which in turn sends the intent to IBI. Now we'll watch the message flow during a non-attack run. This is a zoomed-in view of the pre-processing quadrant. There it can be seen that the pre-processing prepares and sends to DEMI a message. This message contains the counters of the API requests made by the 5 attackers and the 5 normal users toward the NEF in 2 minutes interval. At this stage, the API request counters for both attackers and normal users are perfectly aligned with the expected trend. So we do not expect DEMI to detect any anomalies or unusual patterns. Now, the video is going to zoom in on the DEMI quadrant. Here, we can clearly see the DEMI log. In this log is displayed that DEMI has just received the message from preprocessing, and it is now working on the information it contains. Specifically, the counters of API requests made by the 5 attackers and the 5 normal users. This information is analyzed step by step through DEMI's 2 machine learning layers, each performing a distinct processing stage that transforms the incoming counters into the predictive output used by the downstream component. DEMI has now completed its evaluation, and the results of its processing are displayed. As you can see, in this case the prediction error is 0.0 for both the attackers and the normal users, which indicates that DEMI's prediction, based on the values sent by the preprocessing step, exactly matches the expected values. DEMI, at the end of the evaluation, sends the prediction 0.0 to DTE that concludes that there is no attack. And finally, zooming in IBI quadrant, it can be noticed that IBI doesn't update any counters in the colored boxes of its dashboard. That means no consequent action has been correctly taken. Now the video will demonstrate how an attack is handled by the 4-horse platform components we're analyzing. In this scenario, the 5 attackers significantly increase their API requests to the NEF, while the 5 normal users continue following the expected request pattern. Let's zoom in on the preprocessing log. The preprocessing component has counted the API requests sent to the NEF by both attackers and normal users over a 2-minute interval. This information, the 10 request counters, has been forwarded to DEMI for further analysis. Let's see now what happens in DEMI. DEMI has received the message from preprocessing and is now working on the data using its 2 machine learning layers. After just a few seconds of computation, DEMI detects the attack with the accuracy jumping to 0.90, a value that indicates near certainty. It then sends this result to DTE for that immediately generates an intent to IBI to mitigate the attack. So in the IBI dashboard, we have the counter 1 in the intent not fulfilled red box and also in the threats area, in the under mitigation action box. After a while the intent has been fulfilled, the counter for not fulfilled intents drops to 0 and the counter for fulfilled events now is 1. The mitigated counter, visible in the last green square of the threats section, has moved from 0 to 1, indicating that a mitigation was successfully applied. In conclusion, DEMI has demonstrated the ability to promptly detect NEF attacks, helping to prevent service disruption and potential security breaches, thereby protecting the network and its services.